Okay, so far we have been talking about parallel lines and what happens with relationships when lines are parallel. In this video, I'm going to discuss how we prove that lines are parallel based off of those properties that we have already been talking about. So when pairs of angles are congruent, right, we know that if two lines are parallel and cut by some sort of transversal, then alternate interior angles are going to be congruent, as well as corresponding angles. Okay, so corresponding alternate interior as well as alternate exterior angles are all going to be congruent no matter what, right? That word alternate told us congruent, and then corresponding angles are always congruent if the lines are parallel. Okay, again, these are just review of the properties that we were talking about or have been talking about in class. Our supplementary angles are going to be those consecutive interior angles and the consecutive exterior angles. Okay, remember those are always supplementary. So if we're proving things to be parallel, right, we need to prove those things backwards. So if we find a pair of corresponding angles, right, that are indeed congruent, then the lines are parallel. So essentially verifying is what we've already been doing, but they don't tell us for sure that they are parallel. We have to decide if the lines are parallel. Okay, so again, if we find two lines cut by some sort of transversal and we find corresponding angles that are congruent, then the lines are parallel. The words in yellow are the ones that you're filling in on your notes. So if we find alternate interior angles when these two lines are cut by that transversal, and we find that they're congruent, then they're going to be parallel. Okay, if they're not congruent, then they're not parallel. Okay, same thing with alternate exterior. If we find alternate exterior angles that are congruent, okay, then the lines are parallel. And we can do just as we have done with all of our other ones. You put your A's and B's on there and see if your A's are equal to your A's and your B's are equal to your B's. Okay, we'll discuss that part a little bit further in a couple seconds. So consecutive interior angles, right? The ones that are side by side, same side on the inside. These have to be supplementary. If they're not, the lines are not parallel. If they are, the lines are parallel. Same thing with consecutive exterior angles, right? Consecutive exterior angles have to be supplementary. So if they're on the same side and on the outside, they have to be supplementary. And if they're not, the lines are not parallel. If they are, then the lines will be parallel. So again, there are 5 ways to prove things to be parallel. Corresponding angles, alternate interior, alternate exterior, consecutive interior, and consecutive exterior, right? It's those vocab words that we practice multiple times in class, okay? 2 things that do not prove things to be parallel are linear pairs, because they're on the same line. They don't tell us information about the other line. And vertical angles, again, because they're on the same line and they do not tell us information about both of our lines being parallel. So we're going to look at this diagram here, and we're going to determine whether or not some of these statements are true or false and why. Those are the case. So we have, if L is parallel to M, then the measure of angle 2 should equal the measure of angle 3. So I'm going to get my highlighter out here. The measure of angle 2 has to equal the measure of angle 3 here. So we're going to highlight 2 and 3. Okay, so again, I need it to be one of those 5 things: alternate interior, alternate exterior, corresponding, consecutive interior, consecutive exterior. Now, I'm looking at 2 and 3, and those vocab word is a linear pair, right? So linear pairs are only on one parallel line. If we're trying to prove that line L is parallel to line M, we would have to have information on both of those lines. And here we only know something about M, so it's not enough information. So this would be false, and it's because it's a linear pair. Right? Linear pairs do not prove lines to be parallel. Not enough information there. Okay? So let's see. We're talking about angle 2 plus angle 6. So again, I'm going to mark angle 2 and I'm going to mark angle 6. And they should add up to be 180 if they're parallel. So I'm looking here and I'm thinking, okay, they're on the same side. They're on the outside. So they're consecutive exterior angles. And consecutive exterior angles should add up to be 180. And these indeed do. So this statement is going to be true. And it's because of consecutive interior angles. Or, sorry, exterior. That should say exterior because they're on the outside. And if we can't remember whether or not something is exterior, and it's put your A's and your B's on there. Right, so there's my A's and my B's, and I have A, B, A, B. One's an A, one's a B. They should add up to be 180. Okay. All right. Still got some more true and false here. If the measure of angle 4 is equal to the measure of angle 5, so here's angle 4, and here's angle 5. Okay, those end up being in the same position but different lines, right? They're both in the top right-hand box. So these would be corresponding angles and they should be equal. So our answer here would be true due to corresponding angles, which do prove lines to be parallel. Right, again, you could do your A's and your B's on there. They both end up being A's and they're on different lines. Okay, they have to be on different lines. They can't be on the same one. Okay, we'll just pretend that they've erased everything. So if line L is parallel to line M, then the measure of angle 6 should be equal to the measure of angle 5. So 6 and 5 there, again, are both on line L, right? We know nothing about M. How can we prove lines to be parallel if we don't even know information about both of them? We can't. This is a linear pair. So this is going to be false due to it being a linear pair. Now, linear pairs can sometimes be equal, right? They can be equal when they're both 90. So that piece of information is not always necessarily false, but it's not going to prove that the lines are parallel. Okay, that's the key there. Again, you have to have enough information to prove lines parallel. You have to know information about both lines. So some of the verifying is going to ask you to solve for the value of x that would make the lines parallel. This is absolutely no different than what we've been doing when we've been solving lines that are parallel. So we're going to put our A's and our B's on the picture. We're going to see that they're both B's, so we would set them equal to each other and solve. So we're going to set 3x equal to 60 and divide by 3 to get our value of x. So we get x to be 20. Again, no different than what we've already been doing. Okay. Again, we'll do the same thing over here for 2. A, B, A, B, A, B, A, B. So we've got an A and a B. Remember, A's and B's always add up to be 180. So we've got 2x plus 80 equals 180. Subtract 80 from both sides. we get 2x equals 100. And then divide by 2. And when we divide by 2, we'll find that x equals 50. Okay? Again, no different than what we've already been doing. Let's try it one more time together, and then I'll ask you to do the last one there by yourself. So we're going to put A's and B's on our paper again. This one over here was a B, it just didn't get it. So we've got both being B's. Remember, when they're the same thing, we set them equal. We do not add them. Okay, so we've got x minus 20 equals 70. Add 20 to both sides. So x would be 90. I want you to pause the video here and give number 4 a shot for yourself. Check to see if you get the same answer that I do. All right, so when you do your A's and your B's on that picture on number 4, you find that they're both different. So one's an A and one's a B. And when we set them equal to 180, because we've added them together, we get 15.6. It is okay to get decimals. It's not the end of the world. All right, so let's look at 2 old SOL questions. This first one is kind of tricky, so really make sure you're paying attention. They're asking us which statement must be true. So let me read the statements first. They're saying only M is parallel to N. We need to know that that symbol there in the middle stands for parallel. So 2 lines equals the word parallel. Okay? So M is parallel to N, or only P is parallel to Q, or both are true, or none are true. So the best strategy to go about this is to put your A's and your B's on your picture. So I'm going to do that. I'm going to put my A's and B's everywhere on my picture, on both lines. Okay, so we've got my A's and B's. The first one says to prove M parallel to N. So I'm going to take M and N. So here's M, here's N. And I'm going to pick some sort of transversal. It can be P or it could be Q. It does not matter which one you pick. I'm going to pick Q. So I'm only looking at the right half of this picture. And I'm seeing that I have an 89.9 and an 89.9 both being an A. If they're both A's, right, they should be equal. Then I'm going to check, okay, are they on different lines? And yes, 189.9 is on B and 189.9 is on N. So this is proving things to be parallel. So A is true. A is true. Okay. Now I'm going to pick a different color. I'm sorry for the highlighting happening here for P and Q. So for P and Q, right, there's that line there, and here's Q. And I need to pick a transversal just like I did before. Again, I really apologize for all the colors. I would try to erase, but it's just going to highlight. And then we pick a transversal. Let's pick N as our transversal here. All right, so I've got a B and I've got an A if I'm looking at just the bottom half of my line. B's and A's should add up to be 180. 89.9 plus 89.9 is not going to add to exactly 180, right? If it was 90 plus 90, it would be, but we're not rounding. We're going with the numbers that are exactly there. So P and Q is not true, which means that C can't be true and D can't be true because we found A to be true. So A is the correct answer. I would absolutely make sure I knew how to solve this type of question. If I was you, you might see it on your test. Please make sure you know how to solve this type of question. Okay, second one here. Which shows a pair of angle measures that prove lines A to be parallel to B. So I'm going to highlight A and B. Remember, we have to have enough information on both lines to prove that things are parallel. So here's A and here's B on the first one. Okay, so If I look at transversal C, there is not two pieces of information on it, right? If I look at transversal D, there's not two pieces of information on it. So A is not going to be a helpful choice. And I'm going to come over down to B, and if I highlight A and B, and we look at transversal D, there's no information there, so that's not helpful. And if I look at C, there's two pieces of information already. Okay, so that seems pretty promising, but we're going to come back to it to determine for sure. Let's check out C. If I do A and B on C, notice that on transversal C, there's only one piece. Remember, we need two. On D, there's also only one piece. So C is not true. If we look down here at D, I highlight A and I highlight B. I look at transversal C, only one piece of information. Look at transversal D, only one piece of information. Not enough. So that means B is our only choice that we could conclude is the correct answer. And that's not even looking at the information. That's just looking to see which one gave us enough. So B is the correct answer. If we go across the top, right, we've got A, B, A, B. Notice one's an A, one's B. 120 plus 60 adds to be 180. Okay, we're going to be doing lots of practice of this in class, so if you have questions, please see me.